All right, finally, the mother of all problems, right? We solved this as a linear problem, and we ignored the mass of the pulley. But now the pulley is this, giant, massive thing that's going to interact, right? We got the radius here, which we're not going to use, and then we've got 7 kilograms there, 12 kilograms there. This thing is going to slide across there, right? And we want to find this acceleration, right? Okay. Let me show you how to do this using dynamics, and I think this will pretty much cure you of wanting to use dynamics. Okay, coefficient of Friday. All right. Okay. So let's go ahead and just dynamics the heck out of this thing. Okay, and see where that leaves us. Okay. All right. I'm going to call this guy M1. I'm going to call this guy M2. I'm going to call this guy M3. Okay? Just left to right, M1, M2, M3. And let's look at this thing. I'm going to call this T1. And because this is attached to mass 3, I'm going to call this tension in this thing T3. Okay? Now, the meaty stuff that's going on here is that for this cylinder, this thing is causing a clockwise torque. This tension is causing an anti-clockwise torque, right? And so if we look at that cylinder, if we go R T3, that's clockwise, right? Minus R T1, that's going to equal the angular acceleration of this thing, right? So that's going to equal I alpha, right? Which is going to be, by the way, which will be the moment of inertia. I'm going to use that I is 1/2 mr squared. Okay, so I'm going to substitute 1/2 m2 r squared, right? Okay, and then our alpha, I'll do the standard substitution that it's the linear acceleration at the edge times the radius, right? I'm going to go alpha over r. All right, so we've got, this is the meaty, this is our rotational dynamics equation. We have two other dynamics equations, each of which will be worthy. Okay, but let's go with this, right? Now, let's write that again. So we've got R T3 minus R T1. So radius times the tension in this cable, radius minus the tension in that, because these tensions are not the same. If they were the same, then this would not accelerate, right? Okay. RT3 minus RT1 equals, and then notice that we've got 1/2 M2, and M2 is the pulley, right? And we've got R squared over that. So that cancels one of the R's, right? Okay. So we have M2RA. And then if we cancel again, right, we can cancel another R out. Right? And so we end up with sort of the basic equation here. T3 minus T1 is 1/2 M2A. All right. Now what we have to do is we've got to set up expressions for these guys, for T3 and T1. Okay? For T1, it's pretty easy, right? We've got T1 minus the force of friction, which is going to be mu M1G is equal to M1A. So the tension T1 is equal to M1A. So the force needed to accelerate that plus the force needed to overcome friction, right? Okay. And then if we solve for this guy here, remember it's accelerating down, so I'm going to make the force of gravity positive. So M3G minus T3 is M3A, right? So force down is T3 is M2, M3G, right? And then the force up is T3, and then that's M3A, right? So therefore, T3 is equal to, let's see, I'm going to go M3 minus M. So M3G minus M3A. Now, if you look, I did like two steps at once there, right? Because I had to make T3 positive, or I wanted to make it positive because it's positive here. All right, so what I did was, what did I do? I actually subtracted this from both sides and added this to both sides. Yeah. Just take a moment to realize that I actually did this correctly. I know the answer because, of course, if it's accelerating down, it's the weight minus ma. And I knew that this guy would be ma plus mu mg, right? But maybe you don't know that. Okay, so now let's substitute in here, right? So let's go. We're almost there, really. Okay, so T3 is m3g minus m3a minus T1, so that's m1a plus mu m1g equals 1/2. I keep your masses separate for a moment there. I thought I'd mixed it up, right? All right, now let's distribute the minus sign, right? So we've got m3g minus 1/2. Whoops, where'd the 1/2 come from? I don't have an eraser. m1a plus, oops, I'm trying to get rid of the, I'm making a mess of this. Okay, minus mu m1g is 1/2 m2a. All right, get rid of that there. Right? Okay, so all I did was I just got rid of the parentheses. At least once I figured out that's what I was doing, right? And it's like m3g minus m3a minus m1a minus this guy, right? Okay. Now what I'm going to do is I'm going to put all these guys with a's on it on the right side. So that leaves m3g minus mu m1g is equal to, well, m1a plus 1/2 m2a plus m3a. There we go. We are so close to being there. Now what I'm going to do is I'm going to factor a out of this side, right? A outside of m1 plus 1/2 m2 plus m3. So close. Okay, are we ready for this? Drum roll, please. Okay, acceleration is force causing the acceleration, which is the weight of m3, right? m3g minus force preventing it, right? All over all of the inertia, right? So that'd be m1 has to accelerate, right? And the pulley on the average is sort of like half of it is accelerating as fast as the edge, right? And then plus m3, right? Okay, now let's plug in these numbers. Are you ready for this? I don't have room to show the substitution, so I'll just say it out loud. So m3 is 7, so I'm going to go parentheses 7 times 9.81 minus, okay, and then 0.11 is our coefficient of friction, right? Times 12 times 9.81. That's the end of the numerator, right? Now I'm going to divide by parentheses the beginning of the denominator. M1 is 12 plus 0.5 times 10 plus 7, end parentheses. And I get 2.3217. All right, meters per second squared. Okay, now that's a lot of steps, okay? You've got to set up torque. A clockwise torque minus an anti-clockwise torque is m times a, or I alpha, right? You have to make the substitution. You got to end up with this, right? Then you have to come up with torque 1, or not, I'm sorry, tension 1 minus friction is ma, right? Solve it for T1. Get this guy, right? Solve it for T3. Then you have to substitute. Then you have to, well, it's, you know, actually once, this is all the math, the physics, right? So physics, like a lot of physics, right? I'm going to show you in the next video, I'm going to show you how to do this using energy, which I think is a better way to do it. I'm going to arrive at this expression using just simply energy, okay?